Good morning class 10. In this video we will do question number 14, 15 and 16. Question number 14. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meter from the ground. The angle of elevation of the balloon from the eye of the girl at any instant is 60 degree. After some time the angle of elevation reduces to 30 degree. Find the distance traveled by the balloon during the interval. Now the figure is given with you. Here in this position the balloon is and the girl is standing here and her height is given, that is 1.2 meter tall. The angle of elevation from the eye of girl is given 60 degree, and after some time when the balloon covers some distance, she finds that the angle of elevation is reduces to 30 degree, and we have to find the distance traveled by the balloon during this interval. Now the balloon is given at the height of 88.2 meter above the ground level, but here we are taking the angle of elevation from the eye of the girl, so we will take the right angle triangle here. It means we will subtract the height of the observer, the height of the girl, from the total height 88.2. Now here I have drawn this figure again, and the total distance is given 88.2, and we will subtract the height of the girl, so it will remain 87 meter. And here R, B, N and R, Q, M are the two right angle triangles. Here RM is the horizontal level, and in these two triangles we will use the trigonometric concepts and we will find what will be our answer. You can do by yourself. Now question number 15. A straight highway leads to the foot of the tower. A man standing on the at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from the point. Now here, a straight highway leads to the foot of a tower. It means there is a tower and a man is standing at the top of the tower, and he is observing a car on the road, and that is making an angle of depression of 30 degree. And that car is approaching to the foot of the tower with a uniform speed. Now after 6 seconds, what he observes that the angle of depression of the car is 60 degree. Now we have to find the time taken by the car to reach the foot of the tower from this point. Now the figure of this question is like this. This is a tower. This is a horizontal level. I have shifted upward, and from here the observer is observing a car at the point Q, and after some time it is approaching to the point P, and the angle of depression are 30 degree and 60 degree respectively. And here what is the main thing? The distances are not given to us. Here not PQ, not BP, not AB. No dimension is given to us. Only the angle of depression is given. And one more thing which is given, a uniform speed. Let us consider the uniform speed is x meter per second. Now we know that the time taken by the car from the point Q to P is 6 seconds, and we have to find the time taken by the car from the point P to B. Let us consider it is t second, and the formula for the distance is speed into time. So we can say BP. BP can be taken as x into t. Speed is x, time is t. We have assumed xt. And for PQ, PQ will be 6x. 6 is the time taken and x is the uniform speed. So PQ is 6x. Now as we are doing in the last 14 questions, the same procedure we will do here. We will take triangle ABP and triangle ABQ. Same here, AP by BP is equal to tangent 60, which is equal to root 3. After solving, the value of h is root 3 xt. We can find out. Similarly, in triangle ABQ, AB by BQ is equal to tan of 30, which is equal to 1 by root 3. Solve it. In the last, we will find that root 3h is equal to xt plus 6x. Now put the value of h from equation 1. We can put value of h here because we don't need to find h. So we will put the value of h here. It is root 3 xt, and from here I can take x as a common because we don't want x. We are required only t. Root 3, 3t is equal to 2t plus 6, and here 2t is equal to 6. T is coming 3 seconds. So within the 3 seconds, the car will approach to the foot of the tower. Now the last question of this exercise, and this is very important question. This question comes many times in the board exam. Question number 16. The angle of elevation of the top of a tower from the 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with are complementary. Now in this questions, angles are not given to us. Prove that height of the tower is 6 meter. We have to prove that the height of the tower is 6 meter. Now here tower is, and the angle of elevation from the 2 point, and the 2 points are on the ground. So this is the figure of the question. Here let us consider AB is the tower whose height is h meter we have considered, and from B to point P it is 4 meter, and from the same point B to Q it is 9 meter, and the angles are complementary. So I have taken one of them is theta and the second is 90 minus theta. But the procedure will be the same as we are doing in all the questions. Nothing is changed here. We will take two triangles ABP and same ABQ. Now in ABP, AB by BP, tangent of theta, h by 4 tangent of theta. So value of h is 4 tangent of theta. Now in triangle ABQ, AB by BQ, tangent of 90 minus theta, and we know that tangent of 90 minus theta is cot theta. We have done in chapter 8. Here h by 9 is equal to cot theta. So the value of h is 9 cot theta. Now only for this question we will not compare equation 1 and equation 2. We will not put from equation 1 the value of h here, because we have to prove that the height is 6 meter. So what we will do only in this question, we will multiply both the equations. H into h square, 4 into 9, 36, and tangent theta cot theta. Here I have written, I have multiplied both the equation. So h square is equal to 36 tangent cot. Now cotangent is reciprocal of tangent, so 1 by tangent theta. Tangent to tangent cancel out. So h square is 36. So the value of h is plus minus 6, and it is in meter. But negative values is not acceptable. So the height is 6 meter, and we have proved it. Now you can complete your exercise 9.1 in your fair notebook.